Questions 5 through 7 on the 2017 Grade 12 Euclid Math Contest. Dan was born in a year between 1300 and 1400. Steve was born in a year between 1400 and 1500. Each was born on April 6th in a year that is a perfect square. Each lived for 110 years. In what year, while they were both alive, were the ages both perfect squares on April 7th? So Dan lives between these years, and Steve lives between these years, 1400 and 1500. So we have to figure out, are there any perfect squares in those? Well, after a little bit of math, we figure out 36 squared is 1296, so that's just below. 37 squared, however, is 1369, so that's good. 38 squared, that's 1444. 39 squared is 1521, which is outside of the range. So the only two values that are in the range are 1369, so that's most likely going to be the year Dan was born, and Steve, 1444. All right, so we established the years that they were born. They both lived 110 years, so that means Dan lived till 1479, and Steve until 1554. Right. So there's a period when they were both alive. So 1369 until 1479, and then 1444 to 1554. That's Steve. So they were both alive during the period from 1444 to 1479. And Dan was born in 1369. So there is a period somewhere in this where both of them have ages that are perfect squares. Okay, so from here to here, that's 75 years, 1369 to 1444. And then let's just say that there's some year in there. From that 1444 year till that year, let's just say it's X. I don't know what it is. So that means 75 plus X would be the age for Dan, and that's got to be a perfect square. And Steve's age would be just X, and that's got to be a perfect square. So now we have to fiddle around with this. Okay, well, what's the first perfect square after 75? I think it's 81, right? So that would mean that X is 6. But if X is 6, then Steve's age is not a perfect square. Okay, so that X cannot be 6. So X is not 6. All right. What's the next perfect square after that? I think 81, 10 times 10 is 100. Okay. So 100 would mean that X is 25. 75 plus 25 would give me 100, and that is indeed a perfect square. And then if X is 25, well, that's a perfect square. So there you go. That works. And what do they want? In what year were they both alive where the ages were both perfect squares? Oh, okay. So this plus 25 is that year. I got it. So 1444 plus 25, since X is 25, that year is 1469. So that year is 1469. All right, interesting question. Determine all values of k for which the points 1, 2, 11, 2, and k6 form a right-angled triangle. Let's draw a graph and see what happens here. So we've got a graph, and let's plot this now. So we've got 1, 2, so approximately here, let's say. And then we have the point 11, 2. So let's just say it's around here. So this is 11, this is 1, this is 2. And then we have K6, and we want that to be placed in such a way that this becomes a right angle triangle. K6, so 6 is approximately, let's say, here. So the first place for K would be right there, and that would be 1, 6 as the point, because if you do it right there, you'll notice that will be a right triangle. So that is the first place. The second place for K would be right here, directly above that point, to make it 11, 6. And as you can see, that is also a right triangle. So those two are fairly straightforward, in my opinion. So that means K is either 1 or 11. So now we have to figure out, are there any other values of K? Well, those 2 points are established. Where else can I have K? That's a good question. I could probably make another triangle that's right if it was this scenario right here. I think that might work. So I have to now figure out, where do I put K? So this is the point, and I don't know the value for K, but I know that the y coordinate is 6. So now at this point, I'm just going to use the distance formula. So this is 1, 2, this is 11, 2. And because it's a right triangle, that means we can use Pythagoras. Okay, let's use Pythagoras. So using Pythagoras, we have K minus 1 squared plus 6 minus 2 squared. That distance, but we have to take the square of that. And then this distance is going to be K minus 11 squared. And then plus 6 minus 2 squared. Under the square root sign, take the square root. And then this side, well, that's pretty straightforward. If you're going from 1 to 11, that's just 10, since the y coordinate doesn't change, so that's just 10 squared. Okay, so this becomes K minus 1 squared. This is 16. This is K minus 11 squared, and this is also 16, is 100. So I guess we have to expand this. K squared minus 2K plus 1 plus K squared minus 22K plus 121. And then we've got 32, and then we have minus 100, I guess, if we put it all on one side. If we combine like terms, we get 2K squared minus 24K, and all of that combines to 54, all those numbers. Divide through by 2, K squared minus 12K plus 27. And I'm pretty sure this factors, so I'll get K, 3, 9, negative, negative. So that means K can be 3 or 9. There we go. So all the values of K look like the 1 and the 11, and then I've got 2 additional ones, 3 and 9. The diagram shows 2 hills that will meet at O. One hill makes a 30-degree angle with the horizontal, and the other hill makes a 45-degree angle with the horizontal. Points A and B are on the hill, so that OA is equal to OB equals 20 meters. Vertical poles BD and AC are connected by a straight cable CD. If AC is 6, what is the length of BD for which CD is as short as possible? Okay, so let's recreate this, and AC will go up to here, and then we have to make another one DB. Now, what's interesting about this question is that we want CD to be as short as possible, and that happens if it's directly across. So directly across like that, parallel to, I guess, the horizontal. So let's label this. This was A, C, D, and B. And this is 30 degrees. This is 45 degrees. Now, the distance from O to A, they told me, was 20, and the distance from O to B is 20. All right. So now, I also know that AC is 6, so I have to figure out the distance of BD, so this distance right here. So what I'm going to do is continue these lines, but this time down to the base like this, like that. And that will help me greatly. So I'm going to use now the fact that these are perpendiculars to figure out the length of this guy and this guy. So that's pretty straightforward. We can use, really, you don't have to use trigonometry if you don't want to. You can just use a 30, 60, 90 triangle. Either way, it'll work. If you really want to use trigonometry, it would be the sine of 30 is, if I just call this, I don't know, whatever you want to call it, x, say, it would be x over 20. So x is 20 times the sine of 30. And that, of course, is equal to a half times 20, which is 10. Or you can just use the 30, 60, 90 rule. Same thing with this distance. If I call that, let's say, y, then the sine of 45 is equal to y over 20. Therefore, y is equal to 20 times the sine of 45. And that's 20 times root 2 over 2. So y is 10 root 2. So there we go. So since this is straight across, that means the distance from C to the ground is the same as the distance from D to the ground. So that means that 6 plus x has to equal dB plus y. And 6 plus x we just found out was 10. dB plus y we just found out was 10 root 2. So dB, or BD, whichever way you want to write it, is 16 minus 10 root 2. And I think that should be good enough. Sometimes you can put them in decimal format, and that would be approximately 1.8578. If cos of theta equals tan of theta, determine all possible values of sine theta, giving your answers as simplified exact terms. Well, this is definitely trigonometry. Cos of theta is tan of theta. Well, by definition, tan of theta is sine theta over cos of theta. And you cross multiply to get cos squared theta is sine theta. And then, in my opinion, probably the most famous trig identity is that sine squared theta plus cos squared theta is 1, equal to 1. So that means cos squared theta is 1 minus sine squared theta. So substitute that in here. We get 1 minus sine squared theta is equal to sine theta. Put everything on one side, and we get 0 is equal to sine squared theta plus sine theta minus 1. So now we use a quadratic. Sine of theta would be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And this gives me negative 1 plus or minus root 5 over 2. Okay. Now, very important, these are two values. And I think this might be where some students lose some unnecessary marks. We have two values, right? But not both of these are valid. Why? Well, I think if I convert them to decimal format, it would become a little more clearer. The first one is 0.618. The second one is minus 1.618. Now, if you recall, the sine of any angle is anywhere between negative 1 and 1. It's never outside of that. And you guys remember that probably from the sine curve, right? The sine curve, it goes from 1 to negative 1. So any value outside of this would be inadmissible. And as you can see, this value is outside of that range. So this is the only value that is a possible solution. So that's it. Negative 1 plus root 5 over 2 is the only solution. So there we go. Lynn is driving at 60 kilometers an hour on a long straight highway parallel to a train track. Every 10 minutes, she is passed by a train traveling in the same direction as she is. These trains depart from the station behind her every 3 minutes, and all travel at the same constant speed. What is the constant speed of the trains in kilometers per hour? Well, let's draw some sort of a scenario, and let's talk about this. So, Lynn obviously is driving along. She's just going along, and there's a train station. I'll write S for station. And at some point, we don't really know where or when, but at some point she starts off at the same time as a train. So let's say when she's here, at that point, a train embarks from the station. So if this is the station right here, the train starts from here. So the train starts approximately or exactly when Lynn is here. So that's very important to establish. And that distance, I'll just call X. And I'll write a mark here to indicate that's X. All right. And then eventually that train will catch up to Lynn at here. So I'll just call that point 1. So when Lynn gets to here, the train also gets to there. Like that. Okay, and then this distance I'll call y. So from this, we can figure out our first equation. And remember, we're going to use speed is equal to distance over time, or time is equal to distance over speed, or distance is equal to speed times time, any variation of this formula. At point 1, so we're talking about point 1, this guy right here, the time that it took Lynn to travel from here to here is the same amount of time it took the train to travel from the station to there. So the times are equal. TL is equal to the time of the train. And then we use this formula. So TL is DL over SL. Time is equal to distance over speed for Lynn. And for the train, it would be the same sort of story, DT over ST. So DL is y, just y. And the speed, that is given as 60. And then dt, the distance that the train travels, is x plus y. And that is st. And st, interestingly, is what we're trying to figure out in this question. All right, so that's about as far as we go there. Now, the question tells me that every 10 minutes she's passed by another train. All right, so every 10 minutes she's passed by another train. She's traveling at 60 kilometers per hour. 10 minutes is actually 10 over 60 hours. So if we were trying to figure out distance, we use the distance as speed times time. This was the speed, this was the time. That's going to give me 10 kilometers. So every 10 kilometers, she's passed by a train. So this is 10, and this would be the next time she's passed by train number 2. And this is 10 also. So the second scenario, using the exact same kind of formula, is the time it takes her to go from here to here this time. That is TL is the same as the time it takes the second train to go from the start to there. So that means time for her would be y plus 10, and her speed is 60. And the train, it would be x plus y plus 10 over the speed of the train. But here's the thing. That second train started 3 minutes later, because the trains start every 3 minutes. So we have to add 3 minutes. So 3 over 60, since we have to convert it to hours. And that's a very important part of this question. Otherwise, you'd get the question wrong. Okay, so now we can proceed with this. This gives me that we have y plus 10 over 60 is equal to x plus y over st plus 10 over st, and this is what, 1 over 20? Yeah. Now, this x plus y over st, I actually have a value in terms of y, so let's substitute that in. So I have y plus 10 over 60 is equal to y over 60 plus 10 over st plus 1 over 20. So let's continue with this and bring this over. So we get y plus 10 minus y all over 60. And that's going to be 10 over st plus 1 over 20. So the y's cancel, so that's very good. And then now we're just left with one variable, and that is going to allow me to solve. Great. So 10 over st will be 10 over 60 minus 1 over 20. So that's going to be common denominator, 60. So that's 7 over 60 is 10 over st. And that means that st is 600 over 7. And that would be kilometers per hour. And if you have time, where you can always verify, you can go back and put all these numbers that we got into here and figure out values for x and y and see if this all works out. It's not necessary, but if you have time, especially if you're practicing, it's worthwhile. So the speed of the trains are 600 over 7 kilometers per hour. Determine all pairs AB of real numbers that satisfy the following system of equations. Root A plus root B is 8. Log of A to the base 10 plus log of B to the base 10 is 2. Give your answers as simplified exact numbers. Well, we have a log rule that states that the log of m to the base b plus the log of n to the base b is equivalent to the log of m times n all to the base b. So using that on this, we quickly get that the log of a times b to the base 10 is equal to 2. So that means 10 to the power of 2 is ab, and therefore ab is equal to 100. All right, so that's pretty good. ab is equal to 100, a times b that is. So I guess I can just isolate for 1. B would be 100 over a, and then substitute it into there. I think that should be good enough. So that would give me root a plus 100 over a under the square root sign is equal to 8. So that's root a plus 10 over root a is equal to 8. Now to make things a little bit simple, I will let k equal root a. That means k squared is 8. Let's do the common denominator here, root a. So that gives me a plus 10, and then cross multiply to get 8 root a. Put everything on one side, and I get a minus 8 root a plus 10 is equal to 0. So that means k squared minus 8k plus 10 is equal to 0. And I don't think this factors, so I have to use a quadratic. Okay, k will be 8 plus or minus square root of 8 squared minus 4 times 1 times 10 all over 2. And that gives me 8 plus or minus root 24, which is 2 root 6 all over 2. And that is just 4 plus or minus root 6. But remember, this is k, that's not a. So that means root a is equal to 4 plus or minus root 6. Okay. So I actually have to get ab. So first thing I have to do is get the value for a. This is root a. All right, no problem. Root a is 4 plus root 6. Or root a is 4 minus root 6. So square both sides. That means a would be 4 plus root 6 all squared. So that's going to be 16 plus 8 root 6 plus 6. So a is 22 plus 8 root 6. Similarly, square both sides here. 4 minus root 6 all squared. So that means a is equal to 16 minus 8 root 6 plus 6. So a is 22 minus 8 root 6. All right, I got two values for a. Great. Now I have to figure out my values for b. And if you recall, b was equal to 100 over a. So we've got to do all this math now. So let's just do this one first. b is equal to 100 over a. So b is equal to 100 over 22 plus 8 root 6. And of course, we have to multiply by the conjugate because they don't like to have radicals in the denominator. So when you multiply by the conjugate, what do we get here? 220 minus 800 root 6. And on the bottom, 22, 484. In the middle, the second and third term cancels. That's the whole point of this. So then we get 6 times 64, which is minus 384. All right, so that's going to be b. That's 100 on the denominator, so it just becomes 22 minus 8 root 6. All right, great. So that AB is 22 plus 8 root 6, comma 22 minus 8 root 6. So that's the first pair. Now we will do pretty much the exact same thing on the second pair. And let's see what we get. b is equal to 100 over a this time, as before. So b is 100 over 22 minus 8 root 6. Multiply top and bottom by the conjugate, 22 plus 8 root 6. So we get 220 plus 800 root 6, 484 minus 64 times 6, which would be 384, the same as before. So that's 100 on the bottom, so that just becomes 22 plus 8 root 6. All right, so the next AB, the next pair, is 22 minus 8 root 6, 22 plus 8 root 6. And there we go. Those are the two pairs that they wanted us to find.